we've talked about some fairly more or less standard stuff, and then we've seen how to understand the users, and that's the people who are going to use our intended application. We have an idea of what we want to do, and now how do we design interactions for extended reality? Again, we are here. Oops, we are here. And one key idea, remember, I just wanted to say something in addition to what Mark and myself covered in the previous presentation, which is you have to understand the users. Yes, that's important, but people sometimes they are vocal about what they want, but they are not sure about what they want. And, you know, I would take that from Steve Jobs, who was a well-known designer Nazi, in the sense that he was insufferable, but he was very good at designing. And Steve said something very important. People know what they want, but they probably, they can tell you what they want, but they probably have not known what technology can bring in for them. So you have to understand that there's an important item here. Understanding what people do, how people do it, and what they want is important, but good design requires leadership. What does that mean? You have your ideas, you have to try your ideas and to experiment them if you work. This is a little bit like the problem of a horseless carriage. That's what Henry Ford said that people would want by the time he developed the Model T. So you have to understand people, but you also have to communicate your vision. I mean, you're not a passive whisperer of people. You also have your design ideas. And how do you know what works? Well, one key point is try many different designs. A mentor I had when I was in grad school said to me, one thing that stayed with me, in order to have a good idea, you have to have at least 9 stupid ones. I would probably say 99, but that's probably overdoing. Anything doing is worth overdoing anyway. So idea generation. So you have this first phase. Once you find out the user needs, you can figure out how many different ideas. And the key idea here, the key point here is brainstorming, lateral thinking, try to generate as many ideas as possible. So you have this kind of expansion and elaboration phase where you try to generate as many ideas as possible, and then you try to figure out which ones work and which ones do not. So the key message from our sponsor, try as many ideas as you can, because it's not for sure that the first good idea that comes to your mind will be the best. And that's a problem with people who design like us and want to code this. We get so enamored of our first idea that we lose track of what we wanted to solve in the first place. So elaborate, generate a lot of solutions. As Mao Zedong used to say, let 100 flowers bloom, let 100 schools of thought come about. And these are the opportunities. And then you have to decide which ones are worth pursuing. And repeat, elaborate and reduce, elaborate and reduce. How do you involve people in the process? Try and see what works and what doesn't work with people. So, key important things on the stuff, the techniques I'm going to tell you about. You are designing for people. So there are lots of things that we know about what people can do, what people are good at, and what they are not so good at. Design for different user groups. I mean, people with different needs. For instance, suppose you're designing an application that relies heavily on color. How about people with deuteranopia? Those the daltonics that cannot distinguish red from green. They also they are a sizable part of the population. How about with people with other special needs? So that's important to take into account. Design for the whole user according to social requirements, cultural, emotion, physical, cognitive. We'll cover this. And then we have best practices when we to guide our develop and our ideas. And of course, metaphors are your friend. Designing for humans. This has been one of the most studied parts of the HTI design process. We need to focus on things like perception, cognition, ergonomics. Perception tells us that people cannot process interfaces that are very complicated and provide lots of stimuli at the same time. So we need to focus on their limitations. On the other hand, we are very good pattern recognizers, and we can take advantage of that. And so there are lots of books, one very good and very old, even older than the highly this level from Wickens and Carswell is the work by Scott Card and his colleagues about the human virtual machine. So you need to focus on things that work. Right now, when you are designing for AR, MR, VR, you need to focus on visual perception. How do people see in 3D? And what kinds of visual cues make people understand the synthetic environments we are providing from them, like stereo vision, oculomotor, the conflict of accommodation versus versions. How do people understand 3D sound? How they react to haptic, tactile, synesthetic, and proprioceptive cues. Okay, these are a little bit. Okay, have you heard about proprioception? Okay, that's what tells us that we are. That tells me that I'm standing and you guys are sitting. Our body lets us how we are with respect to the gravitational field. And proprioception can be your friend or can be your adversary. It's one of the factors in cyber sickness. Oh, I cannot move away too much from this microphone. Sorry, I hate being. Wait. Can you hear me, Mark?
Yes, I can hear just fine. That's great, thank you.
I still hear you.
Now you're a little bit faint, but I could hear you before.
I'm anchored here. I'll fix this over the intermission. And you have the chemical sensing system like taste and smell. And then you have the limitations of, have you heard of 7 plus or minus 2? You know, that's the number of information elements that you can process at the same time varies between 5 and 9. It's an old paper, and this is known for a long time. And of course, we can use long-term memory and use associative memory to improve recognition of affordances, situations, etc. Situational awareness is also important. You have to have a good model of the current state of the user's environment and provide cognitive cues to help with situational awareness. These landmarks, procedural clues, and map knowledge are good for making sense of the virtual environment, and we should both support first-person cues and exocentric like mini-maps, worldviews, etc., to help people navigate. And this is an example here, okay? This is an example of an exocentric and the first person when we look at the world. And if you are curious about limitations and features of people, there are limitations to what we can do. I cannot reach longer than my arms extend here. So, okay. And in a virtual environment, oh, you can extend that. The question is, will people feel comfortable if I am do you remember the character Mr. Reed from the Fantastic Four? He can extend his arms and reach. one of the virtues of virtual reality is that we can be Mr. Reed if we want, or we can be anything. We can extend the human motion range, but when interacting with physical proxies, you have to remember the range of motions and what we consider natural posture. And so designing for hand input can involve these two questions for both coarse movements that extend our range of movement and fine scale motions. The gorilla arm syndrome, okay, I have a video for that. I don't need to explain the gorilla. You understand what's the gorilla arm syndrome, right? I don't understand why people like to do 100-kilometer travels with shoppers if they drive a motorcycle in this position. I believe it's a common also instance of this example. If you require people to hold arms in this position for extended periods, this can be very tiresome. You know why? Because their heart will have to develop extra work to keep pumping blood to members, the extremities that are not usually in that position. So for this is an example of ways of compensating. Instead of pointing like this, you can shoot from the hip. So shooting from the hip can be a good way of avoiding the gorilla heart syndrome. Other examples. This is also a good idea, not to put interface elements too close to the personal space of the person, especially in VR. And so this is the no-no zone that I would say around 50 centimeters in front of our nose. It's not a good idea to place interactive content. The main content zone has to do with our vision characteristics. Notice that you should not, even 20 meters can be a lot because our versions does not work very well for faraway objects. And if you want to explore our depth of vision, you should keep the content in this area and not too far away from the user. These points between 77 degrees and 102 degrees are our peripheral vision. You can use that to capture the attention of the person. Here, that's where you should not put content that people should interact here. That's the curiosity zone. I have to turn my head to the back because I don't have eyes in the back of my head, and only curious people will explore here. So this is an example of what distances and zones you should respect. And if you want to place this in a Mercator projection is an example. So you have the workspace zone, you have the peripheral zone and the content zone. And now the question is, are you designing for standing VR or standing XR or for sitting XR? And there's a design space that's different for either of these situations. And sometimes you think that you know what you are designing for, but I can share a personal experience with you. We are developing a tool for looking at 3D images of the human body, of anatomy, and we assumed that all of that doctors that we were designing for would like to stand when interacting with the content. And they said, why? We usually perform our diagnosis sitting. So, okay, then sitting has a different set of constraints. You have a different range of motion, and there are places where you could where you can put natural interactive content when sitting that are different from walking. And if you are walking, then you know that you should avoid obstacles and other considerations. So designing for different user groups is another important issue. So children will have different attention spans and different requirements from adults. Older users have different needs than younger. And that's why we ask for people when doing user testing, have you had previous experience with VR systems? And that's an important issue. People that are familiar with VR systems will know about controllers. People who are not will not know, and we have to be aware of that. And then again, you have people of different heights and arm reach and handedness, left-handed versus right-handed people. Color perception already mentioned. Spatial ability, cognitive or motor disabilities. I have had at least 2 doctoral students that cannot see in 3D. And that's interesting, designing VR systems for people who cannot see in 3D. Actually, I have a little story to share with you that was told to me by Andy Van Dam. That he was, you know Andy Van Dam, one of our fathers of computer graphics. Ivan Sutherland, the inventor of the ultimate display. Yes. So Andy, who's very well known in the computer graphics and virtual reality communities, developed a fantastic demo that he had in his lab, and Ivan Sutherland happened to visit the lab, and he was not impressed when he saw the demo, and he was, why? We have spent so many months preparing this. And after he found out later on that Ivan Sutherland, our founding father, does not see in 3D. So you have to remember that for one person to see in 3D, it's not enough to send 2 different images, one for the left eye and another for the right eye. Also, your brain needs to fuse those images and give you and there is a small fraction of the humanity that cannot see in 3D, and I know personally 2 of these people. So sometimes you think you know your users, sometimes you don't. So, and then you have other types of constraints, like don't make your user look stupid. Okay, this is a good example. Luckily, we do not have head-mounted displays that look like this. But you know, I'm old enough to remember when people who used to talk to themselves on the public environments used to be classified as suffering from some kind of cognitive problems. But now, if you see somebody doing this, oh, he's talking on the phone. Yeah, right. We no longer look stupid thanks to smartphones, thanks to cell phones. And then cultural norms can be, that is tied to gestures, but not only to gestures. Also, perception of color and semantics of color are different in different cultures. Can you respect the limits of physical motion when you are using the interface? Can the users understand how the interface works? Can you develop an interface that's so tricky to use that people feel unease or really unhappy because they are not able to complete the tasks? In fact, as a counter example here, I like those contexts where you say, oh, can you make the volume control so difficult to use that then you can develop a game in which instead of having a simple slider, you have to control the inclination of the slider to manipulate the volume control. That's so stupid, that's funny. But you should avoid that unless you want to make a game the exercise. I don't know if you have examples of other things that violate that physical limitations. So, other people have been here, and this is one of the good books by Ben Schneiderman, Designing the User Interface. It's also one of the first. I think this one dates back to the last century. Yeah, 1998. I thought it was 1994. But Schneiderman compiled a set of user interface guidelines that you can try and figure out how they apply to your user interface. It's a good thing. You can consider this an instance of pattern languages. So it's sometimes difficult to apply user interface design best practices because you have to figure out the context in which they make sense or not. For instance, Ben Schneiderman's guidelines are focusing on desktop. If you want to apply them in virtual reality, some will work, some will not. And providing user interface feedback is good. That's also a good heuristic. Provide reactive, instrumental, and operational feedback so that the users know that they have changed the state of the system. And you should maintain spatial and temporal correspondence in a user interface. Sometimes this is good. That's one common assertion is that people cannot design very well in 3D because our sense of perception is not very accurate. And you thought you have designed a circle, you look at it sideways and the ends do not meet. So, for instance, when you want to design in 2D, maybe you should provide a drawing plane 2D as a constraint that will help people improve things. Another example of constraints that help you, manipulating objects in space with 6 degrees of freedom can also be very imprecise. And there are lots of works that focus on using constraints like using handlebars or axes or limiting the degrees of freedom in order to improve precision and control. And this one is a good one. I love it. Have you heard of GIA? How many of you? Okay, maybe I need to explain that. Okay, so 2 people here have heard of the GIAR 200 model. So GIAR was, I believe it's still is, a French psychologist who observed people how they would do tasks like drawing things and sketching things on a sketchbook. And what GIAR observed is that people use the dominant and the non-dominant hands in different ways. I'm right-handed, so this is my dominant hand. And what if I am sketching on a book, I usually use my non-dominant hand to hold the sketchbook, and I use the dominant hand to perform precision tasks. If I'm left, I cannot sign my name with my left hand. I cannot do most precision tasks. I cannot draw. Well, maybe I can convince myself I can, but every time I try it, it doesn't work very well. And there is this very 1% number of creatures who are ambidextrous, so they can perform precision tasks with both hands. But most people are not. They are either right-handed or left-handed. And by the way, you can extend that concept to high sight. My dominant eye is the right eye, so it guides your vision, and same for the foot. You can extend these things. So we are asymmetrical in our physical capabilities. How can you explore this? You can use, first thing, most people tend to develop user interfaces focused just on one hand and a limited set of motions. Once you start using both hands, you can extend the range of tasks that people can perform with ease. In fact, I would conjecture and make it as a challenge that you can, by getting rid of controllers in MR and VR, you can also improve the way people interact with. That's one of my pet research subjects. And we have a paper here about controller-free VR. So GIAR published this idea. So when we talk about GIAR model, is about this. It's the key idea is that people have used the non-dominant hand for non-precise tasks. Say something like changing the pages of the sketchbook. That's a non-precise task. Drawing, I do it with my dominant hand, and writing and. So if you want to do precision stuff, use the dominant hand, but you can also use the non-dominant hand to do coarse stuff. And of course, now you can just focus on the slide because I've said everything I wanted to say. Okay, any questions about this? So you can also focus on other dominant parts. So again, this was also another set of guidelines for the four cores of user experience design for extended reality. Make interface interactive and reactive. So it's obvious how you can change the status, and it's obvious also to understand what changes you made to the state. Going back to the design principles, it should be clear what you can do, and it should be clear to you what state the system is in and what functions are available to you. Design for comfort and ease of use. Do not use too small text size and also images, and include 3D sound and position audio. So those are the elements. Oh, sorry, I pressed the wrong button. So in terms of, oh gosh, I got too carried away. So keep the user safe, make it look and feel real, make sure people do not get simulation sickness. Again, proprioception tells you one thing, and the virtual environment tells you that we are going at 100 miles per hour on a freeway, that there are people who get very sick just because of that. Develop easy-to-use controls and menus. And examples from the Cardboard Design Lab, where you have a mobile VR app that provides examples of best practices. And this should play. Yes.
Virtual reality.
Cardboard is a bit old, but the ideas are good.
Best practices for design of virtual reality applications. The design team at Google quickly realized it would be much more effective to illustrate and teach these principles directly in virtual reality. After reviewing all of the virtual reality applications currently available in the Google Play Store, as well as many applications for other platforms, the team identified a common set of patterns that were working well, as well as aspects of applications that were problematic for users. We synthesized these findings into 10 distinct principles for virtual reality.
Okay.
We built a cardboard design model to demonstrate them. It's an interactive mobile application that takes the best practices we've learned as an industry and turns them into experiences that even a first-time virtual reality designer can grasp viscerally and immediately. Here's an example. It is important for the user to feel grounded. Depending on your environment design, you may unintentionally make the user feel like he or she is moving. Notice how it currently looks like you are moving forward. But once we add in more objects, it becomes clear that you are standing still and that the cubes are in fact moving. In the application, you can walk through a set of single-purpose experiments crafted to interactively demonstrate more nuanced VR design principles. Shooting balloons teaches you about using rhythm. Riding minecart teaches you about limiting motion to avoid motion sickness.
Well, there are lots of more. Oops. There are lots of more examples, but I'm running a little bit behind schedule. But you have the example here, and the videos are available as well. So use interface metaphors. All of us have heard about metaphors, right? So, and here are examples of metaphors that are used in usable for XR, direct manipulation, reach out and directly grab objects, ray casting for selecting objects, and vehicle movement. Okay, what can you do with this object? And you can sit on it, right? Its shape suggests how do we handle this scissor? We also these scissors. This shape also suggests. The collective name for this is called affordances. Thank you. Exactly. Yes, affordances are important. They the most important way of communicating to people how they can interact with the virtual environment. And they work, I first learned about affordances in this wonderful book by Don Norman, The Psychology of Everyday Things. Yes, now he changed it to Design of Everyday Things because of the publisher, but I think Poet is much better than Do It. So I still stick to the psychology of everyday things. And that's a wonderful book by Don Norman. So you can have false affordances like how can you open a door? How can you pick a cup of tea? So the perceived affordance should match the actual affordance. That's the capital sin to tell people different things than what you can do with virtual objects. So the virtual affordance are related to the look of virtual objects. They should copying virtual real objects is a good idea because then you can transfer motor skills to interface design. And of course, they are important in industrial design. And here are examples of design affordances in XR. Oh, this is one of my favorite. Any of you have tried Birdly as a demo? Oh, this was a demo in SIGGRAPH many years ago. You could fly like a bird, literally. So you'd have this implement. You could have wings, and there was wind blowing on your face. And I think this is the time I have ever felt more immersed in a virtual environment than I felt flying like a bird in this experience. It explored all affordances of work doing like a bird. Let me see. I think we had, and I will leave you with this video. So examples. I'll show you the Birdly movie after a while because it's one of my favorites. So here you have a proxy for the object that you can manipulate using direct manipulation by grabbing it with your hands or a proxy of your hands. And that's an example of ways to communicate affordances. If it looks like a post-it note, then it suggests that you can draw and write things on it. Those are examples of physical and virtual affordances. So affordances give us a clue on how the synthetic virtual world reacts to our actions. And so with this, I would leave, I think it's the good time to make a break and get back here in a couple of minutes. Let me see how many minutes. What's our schedule? Okay. Sorry, 15 minutes. Okay, let's get back here 15 minutes. Sorry, I got a little carried away.